Hi everyone, I'm Mia Gwen A. Aloro, a Bachelor of Science Information Technology student from University of Antique, Tarili Memorial Campus. And today, I will be discuss the Laboratory 1 Data Exploration in HEI 3. So first is the code would use the pandas library to read the iris dataset from the CSV file into a data frame. This is a typical done with the pdread underscore CSV parentheses. pdread underscore CSV parentheses function. And the output of this code would be a pandas data frame object where the data is organized in the rows and columns. The first few rows of data frame might be delayed to give a quick look at the data. So this is the output. Second, this would involve using pandas function to calculate the statistic like mean standards, mean standard deviation, minimum and maximum, sepal length, sepal width, petal length, and petal width. Functions like dot mean parentheses, dot std parentheses, dot mean parentheses, and dot max parentheses. So here are the output, and as we can see, the calculate it calculates its average, standard deviation, minimum and maximum. The mean of sepal length is 5.84 and the standard deviation is 0.86, minimum is 4.30, maximum is 7.90, and the rest. And for the third, for the class attribute, which is qualitative, the code would count how many times each distinct class, Setosa, this Setosa and versicolor virginica appears. The pandas function dot value counts, parentheses, is commonly used for this. So the output would show count of each class, indicating the number of occurrences of Setosa, versicolor, and virginica. So next, the fourth. So pandas describe parentheses functions provides a very handy way to get a summary of statistics for all columns at once. For quantitative column, it will show count, mean, standard deviation, mean, max, also the various percentile values. For qualitative columns, it will show count, number of unique values, the most frequent top, and the most frequent value. It is also possible to display the summary of the attributes simultaneously in the table using the describe parentheses function. If an attribute is quantitative, it will display its mean, standard deviation, and various quantiles, including minimum and median and maximum. So we proceed in our fifth, covariance and coloration. So pandas provides .cov parentheses or covariance matrix and .core parentheses or correlation matrix functions to calculate these statistics which measure relationships between pairs of variables. So output matrix shows how variables change together, while correlation matrix shows the strength and direction of linear relationship between negative 1 and positive 1. For multivariate statistic, you can compute the covariance and correlation between pairs and attributes. Next, so here is histogram. Libraries like libraries like Matplotlib or Seaborn would be used to create the histogram, and the code would involve specifying the data. So here are the output. Uh, a histogram showing the frequency distribution of sepal length with the x-axis representing sepal length ranges and the y-axis representing frequency. So first we will display the histogram for the sepal length attribute by discretizing it into 8 separate bins. So next here, matplotlib or Seaborn would be used. The code specifies the data and creates box plots, one for each attribute. So here is the output of box plot. So next is scatter plot. Code would uh, code would plot one contribute against another using matplotlib or Seaborn. So the output of sepal length versus sepal width is here. Sepal length versus petal length. Sepal width versus petal length. Yeah. Next is the parallel coordinates. So this is a more complex visualization. Code would need to structure the data so that each attribute is an axis and each flower is a line crossing the axis. So here are the output of these parallel coordinates. This is more complex visualization. Code would need to structure the data so that each attribute is an axis and each flower is a line crossing the axis. A parallel coordinates a plot where you can see how different attributes relate across different data points, often color-coded by class. The red is setosa, the green is the versicolor, and the blue is virginica.